What is the coefficient of x cubed times y squared in the expansion of x plus y to the power of 5? Okay, so if we look at x plus y to the power of 5, you can see that it has 5 factors, right? So this is the first factor, the second, the third, the fourth, and the fifth. And to get something like x cubed y squared, notice that it's the same as choosing from which one of these 5 factors do we get 3 x's and 2 y's. So in other words, you can think of it as answering the following question. So how many ways are there to choose which 2 factors give us y? So we have factor 1, 2, 3, 4, 5, and we need to choose 2 of them. And how many ways can we do that? Well, the answer is 5 choose 2. So 5 choose 2. And we saw this is 5 factorial over 3 factorial, 2 factorial. And so this will be 5 times 4 times 3 factorial over 3 factorial, 2 factorial. The 3 factorial cancels out with the 3 factorial. 2 factorial is 2. So you just get 5 times 2 equal to 10. And so this is our answer to the question. What is the coefficient of x cubed, x squared? If you open this out, it'll be 10. More generally, you can apply that to find all the coefficients, and this will give you a nice little formula. So let's see how that works out. Let's put it in a different color. So let's say x plus y to the power of 5. So it's going to be written as a combination of things. So here it's going to be something like x to the 5 times y to the 0 plus some coefficient times x to the 4 y to the 1 plus some coefficient times x to cubed y squared plus some coefficient x squared y cubed plus x to the 1 y to the 4 and then plus x to the 0 y to the 5. So what are these coefficients going to be? Well, we just use the same idea here. So here, from 5 of these terms, we want to know in how many ways we can choose 0 of them to get y. Well, that's just going to be 5 choose 0. For this one, here, in how many ways can we choose 1y from these? Well, it's actually just going to be 5 choose 1. And same for all the other ones. 5 choose 2, which is the question we just answered before. 5 choose 3. 5 choose 4. And 5 choose 5. Okay. And if you solve for this, so 5 choose 1 is going to be 1. So this will just be 1 times x to the 5 y to the 0, and y to the power of 0 is 1, so let's just write this out like this, x to the 5. 5 choose 1 is going to be 5. It'll be 5 x to the 4 y plus 5 choose 2 is 10 that we just saw, x cubed y squared. 5 choose 3 will be 10 also, and that's not a coincidence. We'll talk about this. X squared y cubed and 5 choose 4 is going to be 5. So this will be x y to the 4 plus 1. 5 choose 5 will be 1, just y to the 5th. So you see the binomial coefficients, and that's why they are called binomial coefficients. This is called the binomial theorem, and we'll see it in general. So the binomial coefficients, they give you exactly the coefficients when you expand this here. Notice how there's some nice symmetry going on here. Let's emphasize that. So this 5, 0, these two are equal. These two are equal. And let's say these two here are equal. And very natural reason for that, because, so if we look here, in how many ways can we choose from the 5 factors 2 y's? But when we're choosing 2 y's, it's the same as choosing 3 x's. So choosing 2 y's or choosing 3 x's from 5 factors is the same thing. So 5 choose 2 should be the same as 5 choose 3, which it is if you compute it. Same with these two over here. So choosing 1 y is the same as choosing which 4 will be x's, and so out of the symmetry, choosing which 4 will be y's is the same as choosing which one will be x. So 5 choose 1, 5 choose 4 should be the same number, and so on. So it has this nice little symmetry to it. Now, like we said, this is a general thing, and it's called the binomial theorem. So if you do x plus y to the power of n, you can open it up in this way, where essentially the term with n minus k and k here is just going to be, the coefficient will be n choose k. So the binomial theorem is not just an algebra formula, it is also a counting formula. Each coefficient counts how many ways that term can appear when we multiply out the n factors.